Most of the matter that people ordinarily observe can be classified into one of three states or phases: solid, liquid, or gas. Solid matter generally possesses and retains a definite size and shape, no matter where it is situated. A pencil, for example, does not change in size or shape. It is moved from a desktop and placed upright in a glass. A liquid, unlike a solid, assumes the shape of its container, even though, like a solid, it has a definite size or volume. A pint of water changes its shape when it is poured from a glass into a bowl, but its volume remains the same. A gas expands to fill the complete volume of its container. At a given temperature and pressure, a substance will be in the solid, liquid, or gaseous state. But if the temperature of the pressure changes, its state may become also changed. At constant atmospheric pressure, the state of water, for example, changes when changes in temperature. Ice is water in the solid state. If it is removed from a freezer and placed in a warm pan, the ice warms up and changes to liquid water. If the pan is then placed over a hot fire, the water heats up and changes to water vapor, the gaseous state. Most substances can exist in any of these three states, provided that they do not decompose chemically, as sugar, for example, often does when it is heated in air. Oxygen may be cooled to very low temperatures before it becomes a liquid or solid. Quartz may be heated to a very high temperature before it becomes a liquid or a gas. In most people's experiences, wide changes in pressures are not as common or drastic in changes in temperature. For this reason, examples of the effects of pressure on the states of matter are not common. Often, high pressure machines and vacuums, which are low pressured machines, must be used to study the effects of pressures in the changes of matter. Under very low pressures, matter generally tends to enter the gaseous state. At very high pressure, gases tend to liquefy, and liquids, they tend to solidify. In fact, at the very lowest temperatures that can be reached, helium will not solidify unless a pressure of some 25 times normal its atmospheric pressure is applied. The relationship between pressure and temperature and changes of states of matter is familiar to people who live at high altitudes. There, the pressure is lower than at sea level, so water boils at a lower temperature. Cooking anything in water takes longer on a mountaintop than at sea level. These properties of the three states of matter are easily observed. They are explained, however, by a theory that describes the behavior of particles far too small to be seen. So, as you learn, there are three states of matter: solids, liquids, and gases. Solids generally possess and retain a definite shape and size, no matter where it is situated. A liquid, unlike a solid, assumes the shape of its container, even though, like a solid, it has a definite size or volume. And we know that gases, they expand to fill the complete volume of its container or its bowl. At any given temperature and pressure, a substance will be in the solid, liquid, or gaseous state. But depending on the temperature or the pressure, it can change. Remember, everything in the world is either a solid, a liquid, or a gas.